Studies suggest early humans may have developed the ability to walk on two legs while still swinging through the trees. A surprising new study based on chimpanzee behavior suggests trees played an essential role in the evolution of bipedalism. Walking on two legs is one of the defining features of mankind, and researchers have long assumed that our ancestors developed bipedalism while traversing grasslands. But new research suggests that early humans may have started walking on two legs while still living in trees. In a study published in Science Advances, researchers from University College London, the University of Kent, and Duke University explained how their study of chimps in Tanzania's Issa Valley led them to believe that trees had played an essential role in the evolution of bipedalism. We naturally assume that because Issa has fewer trees than typical tropical forests where most chimpanzees live, we would see individuals more often on the ground than in the trees, explained study co-author Alex Peel of University College London, according to Eureka Alert. Peel added, moreover, because so many of the traditional drivers of bipedalism are associated with being on the ground, we thought we'd naturally see more bipedalism here as well. However, this is not what we found. While studying 13 chimpanzee adults and noting how they climbed, walked, and hung from trees over a 15-month period, the researchers came to a surprising conclusion. According to Science Alert, more than 85% of observed bipedalism took place while the chimps were in trees, not on the ground. The researchers suspect that bipedalism is an advantageous way for the chimps to forage for food while traversing the treetops, safely and effectively navigate the flexible branches, and access as many fruits as possible when they find them. Study lead author Ryan Drummond Clark of the University of Kent explained to The Guardian. To the study's authors, the chimp's behavior suggests that our early human ancestors started walking on two legs while still living in trees. This contradicts the widely held belief that bipedalism developed because climate change started shrinking forests, forcing early humans onto grasslands. Our study suggests that the retreat of forests in the late Miocene-Pliocene era around 5 million years ago, and the more open savanna habitats were in fact not a catalyst for the evolution of bipedalism, Peel told Eureka Alert. Instead, trees probably remained essential to its evolution, with the search for food-producing trees likely a driver of this trait. Study co-author and University College London biological anthropologist Fiona Stewart seconded Peel to Science Alert. To date, the numerous hypotheses for the evolution of bipedalism share the idea that hominins came down from the trees and walked upright on the ground, especially in more arid, open habitats that lack tree cover, she said. Our data do not support that at all. While the study does not definitively prove that humans developed bipedalism while living in trees and not while traversing grasslands as previously believed, it does complicate the original theory. I think we have long told this very logical story that at least our data don't really support, Peel told The Guardian. He added, rather than time on the ground stimulating, it may have catalyzed it, but it was already there. And that fits perfectly with the fossil record because all these early hominins have both arboreal and terrestrial adaptations. Next, the research team hopes to fill in more blanks about the evolution of bipedalism in our early ancestors. What we need to focus on now is how and why these chimpanzees spend so much time in the trees, Stewart told Eureka Alert. That is what we'll focus on next on our way to piecing together this complex evolutionary puzzle.